Hi, this is Mike from Software Confidence. Welcome to another episode of Software Success Disciplines. In the earlier episodes, we put a sensible development infrastructure in place. Things like source code control, continuous integration, and automated building. Now we're going to test drive some interesting behavior into our application, namely stock quoting using the Yahoo stock quoting web service. We'll start with an acceptance test. An acceptance test captures what the system should do from the end user's point of view. As such, it should drive the system from the outside as much as possible. Our system is a web application, so we'll need to put in place some kind of test rig to enable our acceptance test to drive the application. It's very easy to get lost in setting up this kind of infrastructure. So in the spirit of taking small steps, let's first see if we can acceptance test our simple Hello World application. Our Hello World web application is a WAR file containing a single JSP that says hello. To acceptance test it, we'll run it up in an embedded instance of Jetty running on localhost 8080. Then we'll use a web testing tool called WebDriver, which presents us with an API to interact with web applications. It enables us to say things like, view this page, click this button, enter this value in that field, etc. So how can we build all this in code? Begin by creating the Hello World acceptance test class and declare a test case representing what the system should do from the end user's point of view. It should greet the world. Now, this is where we totally have to let go of the inner critic, allow our creativity to flow, and permit ourselves to discover the API that perfectly expresses how the end user would want to interact with our system. So, from the viewpoint of our end user, they would want to view our web application and see the greeting text. I'm just going to piece together the exact greeting text because I can't remember it offhand. The Hello World class says Hello World. Let's see if we can make this API happen. Viewing a particular URL means it's time to turn to WebDriver. I'm going to show you how to download and install WebDriver in a moment. So for now, let's focus on getting the code written. There's a bunch of implementations of WebDriver that use different browsers to interact with the application. You can see the list here. This means you can test your app against most common browsers, Firefox, Chrome, Internet Explorer, etc. We'll get around to that eventually, but for now we just want to test that the application is capable of meeting our acceptance criteria. So we'll just use an implementation based on HTML unit. HTML unit is a Java API that acts like a browser and is designed for what we're trying to do here, test drive a web application. Now we can tell the driver to view the URL we passed in by calling the get method. We implement the assertTextIsShown method by calling methods on the driver too, so we need to make the driver be a field. A straightforward refactoring, introduce field. The driver lets us get a handle on user interface elements of the web application using the findElement method. It takes a locator that expresses how to find the element. We're going to find it using its name, which means we have to rework the JSP a little to put in a named element for us to locate. We'll wrap the greeting in a named span. And now we can use that name in our find statement. Now we can assert that the text we expect to see is the text in the greeting element. Okay, so we've made an attempt to implement the expression of our acceptance criteria. The next thing for us to do is to start the web application in embedded Jetty. Instantiate the Jetty server class, listening on port 8080. Again, I'll soon show you how to download and install Jetty, so let's stick with getting the code written just for now. Tell the server that it has a handler which is a web application. You can see that this Jetty web app context class can be constructed with two strings, the first being the path to the root of the web application, the second being the context component of the URL the app is hosted at. The first argument is the directory that webinf is in, so we can quickly see that it must be source web. And we can host the app at the root of the URL, so localhost 8080 works without any further qualification. Something to note about what we've just done. We've configured Jetty to run as an exploded war by pointing to the root of the web app in our source folders. This is a different arrangement to the one we'll use in the real production environment. That will use a proper war file. We'll put tests in place later to cover this, so for now just note the difference. Back to the code. Our final step is to start the server. That can throw exceptions, and I'm just going to propagate them. If the server fails to start for some reason, this exception will pop up the stack and fail the test, and we can use the stack trace to help us resolve the problem. Our test has started something, so it better make sure to stop it when it's done. Create an after method that stops the application. First off, we need the server to be a field, so the same refactoring as we did for the driver a little while back, introduce field. And now we can stop the server, again propagating any exceptions that might be thrown. How does this test perform when we try to run it? We get a compilation error when compiling our tests. It seems that we can't find the Jetty classes, so it's time to download and install it. Now we have WebDriver and Jetty, so we can try compiling again. Our tests ran and failed. Open up the JUnit report in a browser and have a look at the failure. WebDriver couldn't find the span element named greeting that we added a little while ago. If we go back to the parent test class and take a look at the standard error output, we see that Jetty has told us on the third line that it has no JSP support. Jetty uses the Apache Jasper component for its JSP support, which comes bundled with HighTide, but I just forgot to copy over the necessary Jasper jar files. So back to HighTide we go, into the lib directory, copy the JSP directory, and paste it into the HighTide directory in our project. And again, we have a test failure. This time it seems we found the greeting element in the running web application, but the text in it wasn't what we expected. The real text has hello world in quotes, and our expectation doesn't. We can fix that really easily by changing the expectation to have quotes around hello world, and try again. Green. Fantastic. Now it's time to check in. But before we do that, let's see what files we've added by running subversion status. The first 5 files are not under version control, so they have a question mark preceding them. We're only interested in the last 4 of these, as the build directory just contains the results of running Ant. So, recalling what we did in the previous screencasts, let's subversion add the files we need and check in with an appropriate comment. Have a giggle for yourself at one of my most habituated typos, OUT instead of OUR. Press enter and see confirmation of the files being sent to subversion. Next, leveraging what we did in the previous episode, we check how our continuous integration build reacts to that check-in by looking over at the Piazza monitor. Pretty soon it's updating from subversion, compiling, running the tests, and confirming that we're green. Now we have ourselves in the position where we can acceptance test a web application in its exploded war form. But does that mean we can be sure everything will work when we create a war file and drop it into a deployment environment? Certainly not. I've seen it happen several times that a team works away for days, delighted that their acceptance tests are all green, only to find that the app won't boot when they deploy it for real. Pretty stressful. So we need to plug that gap by testing that our app works in a proper deployment context. We'll get straight into that in the next part. See you then.